There was a time when Earth was an ocean of fire. A period that lasted for hundreds of millions of years. Frequent impacts and endless melting shaped the young planet. Rivers of molten rock flowed across the land. This was the time that the Earth could not remember itself. Earth is about 4.54 billion years old. Yet the first chapter of its history remains almost unreadable. Geologists call this time the Hadean Eon, the first 600 million years after Earth's formation. Very little from that world survives today. The rocks that once covered its surface have vanished. Even the evidence of their existence has largely been erased. In many ways, the young Earth was a planet unable to remember itself. The early Earth was a world that struggled to preserve its own history. The solar system had only recently formed. Earth itself was still growing, gathering material from the cloud of debris that surrounded the young sun. It was not yet the planet we know today, but a developing world still assembling its mass through countless collisions. Across the inner solar system, dust, rock, and ice remained scattered in enormous quantities. Much of this material had not yet been swept away by gravity or incorporated into planets. As these fragments crossed Earth's orbit, impacts became inevitable. Some were small, others were large enough to reshape entire regions of the planet. Each collision released vast amounts of energy. The surface heated again and again, eventually becoming a global ocean of molten rock. The rocks of this world were not solid. They flowed like liquid beneath a sky filled with fire and debris. Although parts of the surface could begin to cool between impacts, the bombardment was relentless. Before one region could fully solidify, another collision would arrive, and so the young Earth remained trapped in a cycle of destruction and renewal. Over time, the number of wandering bodies began to decline. The leftover material from the formation of the solar system was gradually consumed, ejected, or incorporated into larger worlds. Impacts became less frequent. Periods of cooling became longer. For the first time, solid crust could begin to form. But stability remained fragile. Many of these early crustal fragments survived only briefly before being melted once again. Their history was erased and rewritten again. The rocks that formed after each melting event preserved only their most recent state. Everything that came before was lost. This is why so little evidence of the earliest Earth survives today. The first crust may have formed many times, yet each generation was repeatedly destroyed, leaving only fragments of a story that can no longer be fully recovered. In many ways, the young Earth was a planet without memory. The intensity of impacts did not remain constant throughout the Hadean. If we could trace the rate of collisions through time, we would see a long and gradual decline. As the solar system matured, more and more of its leftover debris was cleared away. Some fragments were incorporated into planets. Others were ejected into deep space. And with each passing million years, fewer objects remained to cross Earth's path. Around 4 billion years ago, a new rhythm began to emerge. For the first time, parts of the surface had enough time to cool, to stabilize, and to survive. The young Earth was no longer being reset as often as before. The cycle of destruction had begun to slow. Some pieces of crust survived long enough to persist through multiple generations of change. What had once been temporary could now begin to last. The earliest continental fragments may have started to appear during this time. For the first time in its history, Earth gained the ability to preserve part of its own story. In a sense, this was the moment the planet began to remember itself. And once rock could endure, other systems could endure as well. Water could remain on the surface for longer periods. Interactions between ocean, atmosphere, and crust became more persistent. A new order was beginning to emerge. One built not on constant destruction, but on continuity. As temperatures continued to fall, the character of Earth's surface began to change. Clues to this transformation can still be found today. Tiny zircon crystals from Western Australia suggest that water may have existed on Earth's surface as early as 4.4 billion years ago. By the late Hadean, it may have begun to persist, becoming an active part of Earth's evolving system. Water circulating through rock and carrying heat away from the planet's interior. Hydrothermal circulation was especially important. As seawater seeped downward through fractures in the seafloor, it encountered hot rock below. The water was heated, emerging through hydrothermal vents, driving stable cycles of circulation. The process accelerated the cooling of the crust. It transformed Earth's surface into a place of constant exchange. Processes began to interact with one another. By this time, nearly 600 million years had passed since Earth's formation. The Archean was about to begin. Impacts still occurred, but something fundamental had changed. Cycles had begun to form, and with them, a new chapter in Earth's story began. The fires have faded. Their time has passed, and they will not return. We know them only through the traces they left behind, and through them we remember.